Hello everyone, my name is Siddharth and I am currently pursuing my Masters in Construction Management from SEPT University. Today I will take you through to my second SEM studio project which is Ahmedabad Metro Rail project. This studio focused on the on-site execution and quality control aspect of the project, and we will cover four deliverables named pre-construction activities, QC laboratory, uh, material management, and tools of quality. So let's start with the project brief. So let's start with the project brief. The need of the project or the objective of the project is to enhance mobility between Ahmedabad and Gandhinagar. So currently there are lots of people traveling from Ahmedabad to Gandhinagar and from Gandhinagar to Ahmedabad for work, and Gandhinagar is also slowly becoming the center of IT hub, as there are lots of buildings under construction in the gift city. So to meet current and future demands, a metro rail is proposed. It will cover majorly seven stations from Sector 1 to Mahatma Mandir. The project will be executed on a item rate contract. The total project cost is 724 CR, and the project was bound to be completed by October 2024, but it is running late by 7 months. So let's start with pre-construction activities. Coming on to the planning assumptions, the casting yard is planned based on the number of elements required per month for station and viaduct, and as per that, number of bays, bottom in each base, and cycles per month is decided. So taking an example of eye girder, the contractor has designated two bays with four bottoms in each base, and with two cycles per month, the total plant quantity for eye girder comes out to be 16 numbers per month. So coming on to the execution sequence, first the mobilization process for station and casting yard will be done. After that, the seven stations are divided into three packages. So after which, first work package 1 will include the construction of Sector 10A Sachiwale and Aksutam station. Work package 2 will include the construction of Sector 10, Sector 16 and Juna Sachiwale station, and work package 3 will execute the construction of Sector 24 station and Mahatma Mandir station. Coming on to the mobilization schedule, the mobilization process for station and casting yard will be done parallel. Activities like handing over of land, cutting of trees, barricading works, setting up of temporary electric and water connection, setting up of temporary offices, mobilization of equipments are some of the activities which will be included in the mobilization process, and the overall mobilization process is expected to take 60 days. So the pie chart here shows the cost distribution for electric hours for station and casting yard. So we'll go through the setup cost for station. The security deposit is around 1,82,000, which was taken from the torrent power bill. Panel distribution for panel distribution board, we have considered 12 panels with unit cost of 18,000 rupees. For cabling cost, we have considered 350 running meter of cables having unique unit cost of 150 running meter, and for maintenance cost we have considered uh, 10% of panel distribution board cost and cabling cost. And for illumination works, we have considered 40 lights having unit cost of 2200 rupees. So the total cost at station for setup comes out to be 5,05,850 rupees. And the total operating cost at station comes out to be 29,220 rupees. So the unit rate for torrent power is 11.5 rupees. Multiplying it with the power demanded by the contractor, which is 35 kilowatt, which was also mentioned in the torrent power bill, the total cost comes out to be 29,220 rupees. So coming on to the RMC versus batching plant. So there are some specific advantages of an in-house plant versus procuring RMC, which are full control over quality through up-close monitoring, timely availability of concrete as and when required, and concrete production can be tailored to specific requirements to specific mix design, as the mix design for M55 grade is different for station and casting yard. We can, for if we have a batching plant at site, we can tailor the mix design as per specific requirements. The major disadvantage of having an in-house batching plant versus an outsourced RMC is that initial cost is high. So moving on to the next deliverable, which is the QC laboratory. So a QC laboratory on a construction site ensures project quality, safety and durability by verifying that materials and processes meet standards, and it also helps detecting issues early in the project lifecycle. So the QC lab for this project is situated in the casting yard. The materials tested on site are cement, sand, aggregate 20 and 10 mm, and concrete. The materials which are tested externally are reinforcement steel, admixtures, HT strands, and couplers. So the calibration schedule shows that apart from batching plant, all the equipments are calibrated every year, and the batching plant is calibrated every 3 months. So the total cost for calibration of equipment comes out to be 3,16,620 rupees. The total equipment cost comes out to be 5,14,210 rupees, and the total external testing cost comes out to be 5,17,343 rupees. So based on our observations and employer requirements, we have proposed some area of improvements. So according to the employer's requirements mentioned in the tender, there should be a weatherproof passageway between QC lab and curing tank, which is not provided in the current conditions. So another condition states that there should be a separate lab facilities for soil and concrete testing, which is not currently the case. The they are currently they are not the lab facilities for soil and concrete are not separated. So another requirement is independent telephone lines are required to be provided in offices, but which is not the situation in current stage. And attached toilets, changing room, and shower are to be provided according to the employer's requirement, which is not there in the current state. And based on our observations, a cautionary safety board is needed on the curing tank sheet to warn of the risk of injury from the temperature controlled water. We also observed unorganized storage of materials, Excess cube molds are not maintained properly and designated storage rooms shall be provided. And we have incorporated these changes in our proposed layout, and the proposed in the list of and all the changes which all the improvements which I mentioned were incorporated in the proposed layout. So coming on to the next deliverable, which is the tools of quality. Tools of quality are set of techniques used to analyze and solve problems related to quality. So we observed a non-conformity at Sector 10A station, which is plaster surface not in tub, and we will analyze the causes of this non-conformity using the Ishikawa diagram. So the main causes of plaster surface not in plumb are lack of supervision, no step-by-step plumb and level checking, level dots not marked properly, and not following the plastering checklist. The root cause for this NC is lack of supervision. The contractor's engineer did not supervise the work efficiently. No inspections were made at different intervals, which led to errors being unchecked, and due to which the defects prevailed, or the defects which led to defective plastering work. So coming on to the preventive measures, so so to prevent such type of defects from happening, first of all, the site engineer should check if the survey lines which were obtained from the survey points are in right angle. After which the site engineer should closely monitor, inspect, and confirm the mason's work, and the plastering checklist, which is the step-by-step process of checking work to maintain the quality of work, should be strictly followed. So the corrective action for this non-conformity would be the entire plastering work will be redone by first chipping away the defective plaster, after which the conventional plastering process mentioned below is to be followed. First of all, cleaning the whole surface with brush after water application, hacking the surface for adhesion, after which cement paste is applied on the whole surface, after which level dots are marked, and after laying the cement mortar uniform, it is to be ensured that the mortar is uniformly leveled and plumb is checked during in between the steps or after the steps to catch the errors early, and after and finally filling pores in in plaster with cement paste and finishing it with a trowel through circular motions. To the X bar chart for 7 days compressive strength of M50 concrete. So we got this data from the site itself, and out of 30 samples tested for 28-day compressive strength for M50 concrete, result range between UCL 46.17, LCL 39.98, which is within the internal control limits, but it exceeds the IAS code UCL limit of 43.54 Newton per mm square, indicating excessive strength. Coming on to the histogram for tensile strength of 550D 12 mm diabar, we got this data from the external testing agency, and the frequency for different results are shown here. So according to the IS code 1608 part 1 2022, the minimum tensile strength to be achieved is 600 Newton per mm square From the histogram, we can observe that all the tested steel samples are above the minimum required mark of 600 Newton per mm square, from which we can conclude that the test results are satisfactory. Coming on to the final deliverable, which is material management. So the ABC analysis is an inventory classification technique that divides items into three categories, namely A, B, and C. The objective is to focus on the critical few rather than inconsequential many. For this analysis, we had considered the annual demand of the materials and the rate for these materials were obtained from the ERP software from the site. And after finding the cumulative percentage of the total cost, the TMT bars belong to the class A category because it contributes 71.26 percentage of the total cost and requires close monitoring and management. Cement, which contributes 19.91 to the total cost, falls into the class B category and requires moderate inventory management. Class C materials, namely sand, aggregate, admixture, shuttering, oil, and binding wire, collectively contribute 8.83% to the total cost, and they require less oversight compared to A and B category materials. So coming on to the HML analysis, materials are classified according to their unit prices. The rate of each material is standardized to the same unit. For this analysis, we standardize the rate to metric tons, and similar to ABC analysis, we considered the per annual quantity of materials and the rate was obtained from the ERP software from the site, and the graphical depiction shows that the binding wire admixture reinforcement steel is in the high category due to its high unit cost. Cement is classified as medium materials, which has moderate unit price, and sand and aggregate are designated as low materials since its unit cost is lower than the other materials. So coming on to the EOQ model, EOQ model is used to find the ideal order quantity that minimizes total inventory cost. EOQ tells you how much to order each time, so you spend the least money overall. So So the annual demand of steel, which is 12,536.86, was obtained from the site. Unit cost, as seen in the ABC and HML analysis, was obtained from the ERP software from the site. Ordering cost was calculated by calculating the per day per order salary of the personnel involved in the process of ordering of material. Carrying cost was considered or was assumed to be 5% of unit cost, which is 5% of the 62,540. And using this formula, EOQ was calculated, and for 12,000 for the quantity or the quantity per for annual quantity of 12,536.86, the EUQ comes out to be 129.35, and subsequently ordering cost, carrying cost, and purchase cost was found, and after which it was compared with the actual practice which was followed at the site. So the EOQ was compared with the actual ordering pattern which was followed at the site, and for which ordering cost, carrying cost, and purchase cost was also calculated. And by comparing both the result, we can infer that comparing with the company's current ordering pattern, if the company adopts and changes the EOQ quantity from 170 ton to 129 tons, the company can save up to rupees 15,220 annually. So coming to the EOQ price break model for steel, a model with price break is an extension of EOQ model that considers how supplier discount offers for large orders can affect the optimal order quantity. So for this we have considered a discounted price of 2.5 percentage of the EOQ price, which is marked with green color. The EOQ price is marked with blue color, and the highest price is marked with the orange color. So by finding out the EOQ values for different rates, we can infer that the total cost and unit cost vary directly and linearly, indicating that a lower purchase price results in a lower total cost. In case of EOQ versus unit cost, the variation is inversely proportional and linear, meaning that a lower purchase price lead to a higher EOQ. Hence, among the purchase price highlighted with color, ordering at rupees 16,976 per ton results in the lowest total cost. So coming on to the vendor selection process, the process starts by contractors team visiting vendors factory and checking the quality of the material, after which the detailed report is submitted to the GEC. The GEC scrutinizes the report and makes list of approved vendors. So after receiving the purchase intent, purchase team sends material specification and quantities to approved vendors via email. After which vendor sends the codes for the required materials, which is generated in the ERP software and compared. After which rate negotiation with vendor on the quoted rates happens, and finally awarding purchase order to the L1 vendor. So the figure shows the material store layout. So there are total two material store layouts. Cement is stored in the store two is stored in the store two, and the cement is used for the touching purpose. Um, Store executive and the helpers of the store sit in the store one. As you can see, there's a office here, and the data for this deliverable was also collected from this office, from the ERP software. So some of the materials like white cement, anchors, then grinding machines and hand equipment tools are present in the main store one. And after using 5S tool, we also proposed a improved layout for the same store one, so that the required required materials or the materials which are used often or every day can be taken out more effectively, or it can be obtained to the one to the helper fastly. So thank you for letting me explain my project. I'm lastly I would like to thank all my group members, batchmates, and seniors, and faculties for their invaluable support uh, throughout the semester. So yeah, that's all. Thank you.